One of the most important innovations in all of history was the invention of writing. But for millennia, there was an enormous barrier to the widespread adoption, scalable manufacturing. Before the invention of the printing press, a book could cost more than a house. Whereas today, with roll-to-roll manufacturing, a newspaper can be printed for less than $1. Silicon chips are today's carriers and processors of information, and they are produced in a semiconductor fab, a building which starts at $5 billion a piece. Hi everyone, my name is Ben. I'm from Spark3D in Australia, and we have developed a new manufacturing technology that can 3D print electronics extremely quickly and will one day replace entire fabs with a box. 3D printers that print electronics to electronics manufacturers for $50,000 a year, manufacturers who make things like indoor solar cells. We have a grand vision to one day play a central role in the semiconductor chip market, where we want to replace photolithography with a process hundreds of times faster. But before that, we need to gain experience in related but simpler markets like PCBs and solar. Our beachhead market is indoor solar cells. So indoor solar cells are designed for low light conditions and can power smart home devices and sensors without a plug or a battery. But they've struggled to compete with single-use batteries because of their high costs. And this is why. If you look at the materials that make up an indoor solar cell, one stands out: gold. Our printer is able to replace the gold with copper, reducing the material costs by 90% while increasing throughput and performance, really unlocking the potential for this technology. And this is how we do it. This is our MVP printer called MicroFab. MicroFab deposits materials in an entirely new way based on electrochemistry. It uses electricity to deposit metals, ceramics, polymers, and semiconductors. Our number one unfair advantage is that our method is extremely scalable and patent protected. We can print extremely quickly at high volume and high resolution. Compared to other manufacturing methods, we are much more flexible. We can print multi-materials and in true 3D. And last, we're first to market, and we have a small high-performance team that can move really fast. We've made a huge amount of progress in a very short time. The company was only formed in February, and in the last 3 months, we've talked to over 60 technology businesses and academics around the world, turning 2 of those into paying customers, and have successfully raised $3.7 million seed round in Australia. We've made a huge amount of progress in a very short time. The company was only formed in February, and in the last 3 months, we've talked to over 60 technology businesses and academics around the world, turning 2 of those into paying customers and successfully raising a $3.7 million seed round in Australia. Before those conversations, our key assumptions was that inkjet users were not satisfied with the material quality, high resolution was very important to manufacturing, and that prototyping was the sweet spot for a 3D printer. After we've confirmed that inkjet users are not happy with the material quality, we found that multi-material printing was much more interesting to customers than high resolution, and that the transition from prototype to manufacturing is the really hard part. With 80% of our beachhead market in year 5, our projected profit is $5 million a year. Our key drivers are the price per unit per year and the total number of printers we sell through market size and share. We save 1 kilogram of CO2 for every IoT sensor we power with an indoor solar cell. With 80% of our beachhead market, we can save 24,000 tons of CO2 per year. But we could have an even bigger impact in outdoor solar and batteries. Plus, our process is more efficient, creates almost no waste, and we have a plan to solve the e-waste problem by turning it into e-ink. We have an amazing team. Between us, we have a great combination of experience in hardware, software, and material science. Our leadership team has startup experience. All 4 of us have either previously started a startup, been the first employee of a startup, or started a research group. Our dream is to democratize the electronics manufacturing industry so that anyone with an idea for a breakthrough technology has almost no barriers to implementing it. That's our biggest contribution to solving climate change, enabling the great ideas of others in solar, batteries, and computing. Happy to answer some questions for Q&A. Thank you very much.